Right, welcome to the tutorial 5. We're looking at inequalities. So the first thing we'll consider is for part A, what is the language. So we're looking at the language less than and greater than. So real numbers less than or greater than 2, less than minus 2, or numbers greater than. So we want to write it as some variable, a real number, x is less than minus 2, or x is greater than 5. So we could do the number line for this, greater than 5 or less than minus 2. Okay. All the real numbers between 3 and 8. So the language is very informal, but we're formalising this by making it an interval, but not including 3 and 8, so that means we're going to do that. So between 3 and 8, we might put it as an intersection, recognising this as an interval. An interval, an intersection, an and. So in this case, we'd have 3 not included and 8 not included. So that would be the solution for this one. Okay, very useful, I think. Okay, so all right, the next thing we're going to be looking at is solving some inequalities. Now, there's two ways that we can do this. We can just plough along and do the, here it is, and start solving it like we would an equation. But what's the geometric interpretation of this? That's the thing that I'm interested in doing here. What is the geometric interpretation? So I'm going to open another window and use technology to help us establish this. But before I do that, what I'll do is just bring this window over here, so I can just sit there, that's fine. We'll look at that in a moment. We'll just do some checking because we use this one to check, don't we? Alright, so we want the geometric interpretation of this, and this can be treated as a y, and this can be treated as a y. So we're looking to give a geometric interpretation. Now y equals x, we know, sits like this, y equals x, but shifted down to minus 4, it'll be of this kind of line. Okay, and 4, 5, 6, 7, 8, 9 would be around here somewhere. So we'll put 9 about there, and we'll put a dotted line. And they're the two things that are of interest in the geometric interpretation. We've got the line 9, and we've got y equals x minus 4 here. So the question then becomes, how do we interpret this? Which way means less than 9? Well, less than 9 would be this. So somewhere here there's a less than, so we're going underneath the 9 and not including the 9. And then we've got to understand how that works. To do that, we need to solve this. So the way that we would solve this is that we would isolate x as we would for a normal solution. So we would add 4 to both sides, that's just undo. So x would be less than 13. So this one here is 13. So that's the one that we're interested in. That's the x value, 13. And it's less than, and that means that all the values of x going that way. Okay. So what's under 9 and less than 13? What's under 9 and less than 13? So let's have a look at this using technology. And I'm aware that you haven't seen this before, so that's fine. Under 9 and less than 13. So which way would we look at that? Let's just finish this before we go. So that's the way we're going, in that direction, but under 9. So everything that's under 9, and there's our function. So it can't be on this side, it's got to be on this side. So all of these values here should be the solution, the region that's the solution to this particular problem. Okay, so let's check that with technology. So we've got x minus 4 is less than 9, and let's see what that brings us. Now, there it is, there's our 13, and so underneath 9 and everything to the left. So let's have a look at that, and that looks to be the correct region. Excuse me, everything underneath. Now, what we can do is we can do a plot of this, and we can ask for a bit more information. And the information that we'll be looking for is to see that x goes from, say, minus 5 to 14. So let's say 14. Let's see what that looks like. And just to that, x needs a column there, just to help it understand. Set notation. So it's giving us a plot all the way through the origin areas. So it's giving us a good indication of how this is working. So there's our 13. And this is the solution where it cuts the x-axis for y equals x. But this is our interpretation here. So this is a very important way to describe what's happening with these values. Okay, so it's one thing to solve for a value. Okay, it's another thing to understand the region that it has. Okay, and that is the geometric interpretation. So we're looking to do that all the way through. All right, let's have a look at 2x minus 3 and is 7. So now we've started that journey. What we can consider is 2x minus 3 is greater than 7, so we'll put a 7 in here. Given that scale, now that'll be a dotted line, and 2x minus 3 would be down about here, and 2x is very steep, isn't it? So 2x is going to go like this, down, and so we're going to get some value of x there. And when we solve for x, that's the value that we'll end up with. So if we go ahead and solve for x, so we're going to add 3. So we get 2x is greater than 10, and divide by 2, and so we'll get x is greater than 5. So what this is telling us is that we come here to 5, and we go not inclusive, and we go off in that direction. So that means that everything in this section here, at this junction here, represents the region or the area. So that's what this inequality actually means. So getting these two pieces of information together and using them to solve these problems is not straightforward. Okay, if you just solve it for x is greater than 5, you may not understand what it is that's causing that. Okay, so we'll do 2x minus 3 is greater than 7, and so we'll have a look at that. And that's the same way. Now I can do the plot again, but you can see it's 5. So I might just squish that up a bit so we can see our drawings. Okay, we can see that that 5 is there. Okay, and so that's giving us all of that information above 7. That's what that actually means geometrically. So it's important that we recognise that in doing these, there's not just finding the x value, but it's asking what does that mean. It means the point where we start to generate the actual inequality, y for y. Okay, the actual inequality y for y the number and y the function. Okay, all right, let's keep going with it. Let's see if we can put some more together. What have we got for C? Minus 2x minus 8. Minus 2x is less than -8. So what does that mean? Well, we've got to have a look at our geometry, okay? And I'll put -8 down here. And minus 2x is a negative, so that's a minus x. So minus 2x is a bit steeper, isn't it? Twice as steep. Okay, and this is less than. Okay, less than. So less than is going to be pointing down, isn't it? It's one of these areas here, but we're not sure where. And what's that value? Because that'll help us decide which way we go. Okay, so if we go ahead and solve this, dividing by -2, ring the bell. Right, what does that mean? It means that x is minus over minus is a plus, so it's 4. But what do we have to do? We have to reverse the inequality. So x is greater than 4. So this value here is 4. Okay, and that means that we're going to go greater than 4 in that direction. Okay, greater than 4 in that direction. So this means, of course, that this is now our region, going off and understanding our region. Okay, so where we pick these up, it really is important that you understand how to develop an intuition about them. And sometimes we won't be able to do that. We'll just have to deal with the numbers that are there, and that's not always straightforward either. All right, so I'll bring D down into the new page. I've got plenty of pages, so it's not so much of a thing. So 13 minus 3x is less than or equal to 20. So that's okay. We can have that. All right, so what we want to do is consider what does this one look like? Y and y again. So 13 minus 3x is a plus 13 and a minus 3x. And we've got 20. So we've got a 20. This time it's a solid line because it's, look at that. Okay, it's a solid line. So that's this one, not a dashed line. Now we've got 13, so we've got 13, so if we do 20 there, 10, 13 will be about there. And minus 3x. Minus 3x is very steep. Okay, minus 3x is in that direction. So then we need to know what the region is. So greater than 20, wow. Greater than 20 will be that way. But which side? So we need to solve. So 13 minus 3x. So we'll subtract 13, which will bring us to 20 minus 13 will be 7. Okay. And then we can add 3x. Or we can just divide by minus 3. Ding, 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 ding. What does that mean? It means that we have to reverse the sign. Okay, now minus 7 on 3 is 3, 2 1/3. It's 2 1/3. So we need to go to 2 1/3. So 2 1/3 will be here somewhere. There it is. 2 1/3. So we can colour that in. And off we go. Okay, so what that means is that this region up the top here is the region of interest. I'm going to change the colour because there's a lot of writing there. So this is the region of interest. It's above and all the way down there. Above 20, okay, and all the way up to the line. So that's the geometry that satisfies this particular algebra. So a lot of work to do there to understand that. It's the case, and you can check it with technology, but I'll let you do that. Wow, so that's interesting, isn't it? Interesting that we're able to generate that. All right, so we're up to E. Now in this case here, I want to do it two ways if that's possible. I want to do it as 3x minus 4 and 7 minus 5x. And the second way I'll do it is 3x minus 4 is less than 7 minus 5x. So what I can do is I can group these. I can add 5x to both sides, and we can get 8x minus 4 is less than 7. So based on what we've been doing, 8x minus 4 would put us down, and 7 would be here. So minus 4, that would be our x, minus 4 is here, and it's also a solid line. And I don't know why I drew that one in actually, minus 4. Didn't need that, sorry, just where it cuts the x-axis. So that's good. And 8x, so there's our minus 4. 8x is very steep. So 8x is going like this. Okay, and let's solve for that now. So we can add 4. So 8x is 11. And x is 11 on 8. So this one here is 11 on 8. Now that's 1, 8, 9, 10, 11. So it's 1 and 3 eighths. So 1 and 3 eighths, which is 11 on 8. Okay, so it's less than or equal to 7. So 7's here. Okay, now which side is it? So 11 on 3 x is less than or equal to, so we colour it in. We go like that. Okay, so Sx is less than 11 on 8. Okay, so that means less than 7. So we've got our interpretation here and solving it like this. Now look, the other way that I wanted to do that was to consider the two lines, the two regions. Now we're going to end up getting the same value of intersection if we go through and solve. 3x minus 4 is a very steep 3x minus 4, okay, and minus 5x at 7, so we'll put 7 there, is a very steep minus 5x. So they intersect here. I'm not sure whether it's above or below. Whatever that x value is going to be this one, 11 on 8. It's going to be the same value. But the interpretation is going to be slightly different because the line is showing the 3x minus 4, which is this one here, is less than or equal to, 3x minus 4 is less than or equal to 7 minus 5x, or minus 5x plus 7. So that's the region there that we're looking at. So these regions, it's very, very interesting, isn't it? So we're going to use technology to check that one, just so that we can get a bit of experience from it. So we've got 3x minus 4 is less than or equal to 7 minus 5x. So let's have a look at that. And so what it will show you is the blue one is 3x minus 4 being less than. So at this point here it becomes more than, but being less than. And so it's showing this region here. And I have a different scale, so mine's a bit more open. So all of these kinds of values. Very interesting, isn't it? Very interesting. So just how you interpret that is quite a way forward. Now, for this one here, let's just pop back on here. Okay, what we're looking for is x is less than. So this is our solution. So that doesn't change in the cases that we're looking at. Okay, but just be careful of what you take as the actual meaning of the thing, because this is not two curves. This is one curve. So just be careful about that. This is two curves. So just be mindful of your regions there, because that's important. All right. So that was E. And now we're looking for F. So, oh dear, F is just a bit of gymnastics, isn't it? I don't know why this is so important. Doesn't really contribute to the concept. It's only that we're doing gymnastics. So we've got 3 times 4 over 2 minus 3 times x over 2 is less than 10. That'll cancel. So that'll be 6. 6 minus 3x over 2 is less than 10. So the geometric interpretation shows a gradient of 1.5. Okay, so this is the point where your interpretation would stick. Now we can do other things here to solve for this. So what I'm suggesting here is that this is in fact 10, and we've got 6. So we've got a 6 here. So that's about right. That'd be our x-axis. And so 3 is 1.5. Negative, so it's like this. I'm suggesting this. Negative 1.5, it's straight. And so what we'll have is less than 10, so it'll be one of those. And so now what we need to do is find this value and understand whether we're going to the left or to the right. Okay, to the left or to the right. Okay, so which one is it? And then we can only do that by solving this now. So that's the suggestion, that you get it to some form where the geometric interpretation is representative. That is, we haven't fundamentally changed the scale or size of the computation. We've just reflected that they're equivalents. They're in an equivalent form so that we could do our geometry. Now if we go ahead and do our solutions, we can take 6 away. So minus 3x on 2 is less than 10 minus is 4, multiplied by 2, and so we get minus 3x is less than 8, and now we've got to divide by minus 3, make a noise please. So x is greater than minus 8 on 3. Okay, x is greater than minus 8 on 3. So that's the solution, but what that means is that we're going this way. Okay, so in our development of the region and what it looks like, we're going to be going that way. So everything that's less than 10 will be this way. Okay, all the way across. Okay, so you can put that into technology to check. Of course, that's what you want to do to maintain the integrity. So we've got 3 divided by 2, then we've got 4 minus x is less than 10. So we'll just see if that pans out right. Hopefully it'll put that's it, that's what we want. And at this point that looks like what we've got. So there's our 10, and it's coming down to our values. So we could just do a plot of that a bit more. I'd like to go up to the plus. So I'm going to plot that. Put a comma, call an x, and ask it to do an x from minus 5 maybe to plus 5. Let's have a look at that, see what that looks like. And so that'll give us our x-intercept. It'll give us a similar picture to the one that we've got up here. Okay, so you need your skills, you need your interpretation, you need your development to be able to do that. So never ever straightforward. Okay. All right, for G, I'll do G and I'll finish this question and then I'll start a new video. But for now, I'll just do this one. So again, we're looking at an amalgam of ideas here with regards to, first of all, gymnastics. So this is going to be quite an interesting bit of gymnastics. So we've got to do the long way first. Over 3 minus 2 times 5 over 3. So 2 2s are 4x minus 10 it's 1/6. So what we'll do is we'll multiply through by 6. So every term gets a 6. So we do 6 times, 6 times, 6 times, 6 times. Okay, so we do each of those, and that will give us 6 fours are 24x, divided by 3 is 8x, 6 tens are 60, 60 divided by 3 is 20. 60 divided by 6 tens are 60, and then we've got they cancel, so that's 1, and then 6 fours are 24x. Alright, so we've taken the fractions out, we've made it, so that's quite possible what our geometric interpretation would want to examine at that point, but we need to find the threshold value, so we can go ahead and put them on the same side. So we can just add them to both sides, and we can add 20 while we're at it. And so we've got 32x is greater than 21, and divide by 32, and x is greater than 21 over 32. Now 3 7s are 21, but 4 8s are 32. 3 12s is 36, 3 11s are 33. So effectively that's your value. So we'll just go to technology to help us with this one. And so what we've got here is, where did you go? That one, please. Okay, so we've got 2/3 2x minus 5, and we do the symbol on equals, and then we do 1/6. Put a space in before you put your minus to help it understand the 4x is over there. Let's see what that looks like. 2/3. So there's your two lines, and the threshold point there is 21 on 32. There it is, it's the same solution, 21 on 32. And so that value there denotes the region to the right for these particular values. So if we've got both of them coming down like this, that's our value, and it says greater than or equal to, so we can go like that. And of course, the one is less than the other. So the 1/6, this blue, this orange one on the left, which is this one here, so it's going along that way. So it's all of the values this way. That's all we're looking for there. So that's showing the undervalues for that. So they can get a bit complicated in their interpretation, but certainly it's nothing to worry about. Alright, for H, and I'll do this one and then we'll start a new video. So for H we've got minus 2, 3x plus 4. And so I'm just going to solve because I know that this happens in Pearson. So I'm going to minus 4 everywhere. So that'll become minus 6, 3x, 15. Then divide by 3 everywhere. So we get minus 2, x, and 5. So that becomes the solution for this particular one. Now 3x plus 4 is just a shifted steep linear. Okay, and it's between minus 2 and 19. So if we exaggerate that a bit and just draw it up there like that, 19 and minus 2. So we can put that in and we'll see that it's the same thing. Alright, so it's just the interval of connection. Just very quickly, so we can do minus 2 Let's have a look at that. And so what that's showing is just the interval between -2. Okay. Now if we plot that, I don't know if we can plot that interval that way. Let's see. I don't think it'll like this, actually. Yeah, it's not. It's a plotting function. I think it's going to give us what we want. So we would need to plot some things separately. So if we just plot the 3x minus 4, and we can actually do, if you like, we can close the restrict this, so it's -2 dot dot 19. And so in effect we're mimicking the -2 down here, and the 19, they're the endpoints. The endpoints of those. Okay, that's -2, and that's 19. 16, 17, 18, 19, you can just see it there. Strain your eyes. So that's 19. That's the interval in which this exists. So that's our number line interval as well. All right, so we'll come back and do the next question in another video. So there'll be probably a couple of videos for this tutorial because there's a lot in it. All right, we'll be back soon.